Good afternoon, Doctor. This is Noga Frank. Going to present. I'm going to present um, a presentation concerning a research proposal concerning explainable cloud forensics in virtual machines in heterogeneous disparate data centers. Uh, this is the content of the presentation. Cloud computing. It's a delivery of computing services over the internet. This some statistics that shows the coverage of the cloud computing service providers on the market and Amazon Web Services. It is occupying 33% in terms of provision of cloud computing services to the people. This diagram here shows the cloud market share for the various companies, the various service providers. And this other graph here shows the anticipated amount of money that is projected to be got. The anticipated amount of money in terms of billion US dollars that is it is projected that cloud data center market is expected to grow up to 16.45 billion US dollars by the end of 2033. This other graph here shows the cloud security incidents that have happened. Now, as the people or end users use these services, cloud computing services, security concerns have also emerged. So as people use these cloud computing services, others use them for bad intentions, propagating malicious activities or malicious acts, perform malicious acts on the cloud. So that's it's a concern. The data centers, those are cloud service providers provide IT services to the end users through data centers. Data centers, those are facilities that are used by cloud service providers to provide storage of enormous amounts of data and provide IT services to the end users. They are built on primary components of network, compute, and storage. Distributed data centers, those are data centers that are dispersed in various locations, that are situated in various locations, dedicated to provide or bring services near to the end users. For example, MTN has 66 physical data centers that are dedicated to provide services near to the people. Then cloud data centers, those are data centers that are being provided to the end users using virtualized technology, leading to the development of they are also called software-defined data centers because of the virtualization technology that allows the creation of various instances. These instances can be of VM instances, they can be storage instances, for example, virtualized hard disks. They can also be instances in terms of applications that are provided from the virtualized layers of abstraction. Now, heterogeneous data centers, those are data centers that are geographically distributed, and they provide a wide range of workloads, of services to the end users. But these ones are dispersed, geographically dispersed or separated from each other. As you can see from this visualization here, So users from LIDA are being provided with a public cloud data center, and users in Minimokono are being provided with still a private cloud data center. But as you can see, infrastructure as a service for users in Lila is different from the infrastructure as a service in those users in Mukono. These ones are being provided with BVMs on top of that, graphics processing units. And these ones are being provided with only VMs. Still, platform as a service, I can see platform as a service. These ones are being provided with the platform as a service, whereas these ones are being provided with software as a service. So this diversity here, the different services or the different computational resources that are being provided by this Google Cloud service provider using an OpenML cloud management platform as a central orchestrator delivers different diverse kind of workloads or diverse kind of services dedicated to accommodate a wide range of user needs. So these data centers here are distributed in nature, and they provide diverse computing resources to different people within these different regions. So the heterogeneity comes from the fact that these people here are being provided with different computational services. So this is the an architecture of the cloud computing platform, Um, cloud forensics, as we have said, as far as more of the people, as the cloud services, as the cloud services become people provision, as the cloud service providers provision these services to the end users. So if the security states are also a challenge. So once someone or an attacker performs, a cyber attacker or can perform malicious activities from the cloud. So as you can see, this heterogeneity here within you see these services here. So malicious actors can also come in from this from these services here to frustrate the users who are using these services. So these attackers here, we need to identify crimes or threats that happen in the cloud. So we need to perform what we call cloud forensics. Which is a process which involves identification, preserving, examining, analyzing, and reporting. So previously, the traditional methods that were being used to extract evidence to identify that really a cyber threat has happened in the cloud, we need to use traditional cloud forensics methods like signature-based detection. These are traditional methods. So that were being used, they are slow and they cannot analyze massive volumes of data, and they have high false positives, and rely on predefined set of known threats, and they struggle at predicting new threat patterns. So because of the problems that are coming from that fact, you need to come up with a deep learning framework that can be used to analyze the massive volumes of data that are generated from the cloud, and also hasten the process of cloud forensics, and also help to come up with explanations as how detailed explanations that can be used to generate reports that can be used for this admissibility in the courts of law. Also, this deep learning framework can be used to bypass the virtualized layers of abstraction. As one of the problems that are faced with the other traditional methods is that they cannot penetrate through the virtualized layers of abstraction to extract evidence from. from there. So we need to develop a mechanism that can be used to 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 come up with that kind of evidence. Of evidence. Main objective to develop um, the planning framework that can be used by forensics investigators to generate data by the virtual machines. Virtual machines is our point of interest here because each as here we have seen here, they are being the OpenAI provide different services, but still virtual machines are part of the services that are all the digital assets that are being provided. We need to extract evidence from the virtual machines using this new developed deep learning framework. So among the services that are being provided, or computational resources, VMs are part of the computational resources that are being provided. So specific objectives to identify the features of the VM, identify important features that are really necessary for detecting evidence that really a certain criminal activity has taken place. We need to find the features that are really contributing to that kind of output that a given virtual machine instance has been compromised. When you need to develop and train the build, train, and evaluate the planning models for evidence detection among the VM instances. Then we can have to incorporate what we call explainable AI after training the models. In some related literature, all is the works, the methodology. Then it's the architecture. For example, an LSTM will be built on two layers: the input layer having 50 neurons and the output layer having one neuron. Then this will be we shall have to evaluate the deep learning models using these matrices. Then these are how I'll map specific objectives to the methods. Thank you, Doctor, for your kind attention.